Hello, Keystone students. Welcome to this video today on our word problems for systems of equations. All right, so I want you to please take note as we work through this as a couple of the steps. You will be doing a worksheet that you're going to hand in later today. Each question will be worth 4 points, and I'm going to demonstrate exactly what I'm looking for so that there's no surprises on what I want the answers to be. Okay, so an example, an art museum is selling tickets. Adult tickets cost $7. Children tickets cost $2. The museum sold a total of 45 tickets and earned a total of $245. Set up a system of linear equations to determine how many adults and children's tickets were sold for the museum. All right, so your first point here when you work through your worksheet later is you are going to get a point for defining your variables. So in this case, I'm going to say that let x equal the number of adult tickets sold, and y is going to be the number of child tickets sold. Okay, so that's your first point by just simply defining your variables. The second point that you are going to get is you are going to get that for setting up your equations. So what I notice here from setting up your equations. So here we have two totals. We have a total of 45 tickets sold, and we had a total of earning $240. So the number of tickets is just going to simply be in adding the number of adult tickets, which is X, to the number of Y tickets, which is our child tickets. That's going to equal 245. The other one's going to come from this sentence right here, that adult tickets cost $7 and that child tickets cost $2. So now we have our system of equations, and now we need to solve, and this is where your third point is going to come. In this equation, you could have two different options. You could either use substitution or elimination. If you want to use substitution, just make either this first equation here into either x equals or into y equals. I am going to choose to do this through elimination. So I'm going to take my first equation. I'm going to choose to eliminate my y, so I'm going to multiply everything by -2. So I'm going to negative 2x minus 2y equals negative 90. I am then going to add these two equations together. So 7 minus 2 is going to be 5x, plus 2 minus 2, those two cancel out, and we are going to get 150. Now I'm going to divide both sides by 5, so I get that x is going to equal 30. And I'm going to plug this in to this top equation here, and it's going to be 30 plus y equals 45. Solve, and I'm going to get 15. Again, my fourth and final thing I'm going to do is I'm going to write a sentence summarizing what happened. So it says the art museum sold 30 adult tickets and 15 children tickets. Notice here in my sentence, I do have the units as well as the numbers, and I say specifically what has happened. Okay. Moving on to the next example, we're going to do the exact same process, a very similar problem. I would pause this now, do it yourself, and then you can come back and check it. But again, in this case, that x is going to be the number of adult tickets, and y is going to be the number of child tickets. So we have two totals. One is going to equal 140. One is going to equal 864.75. So the total number of tickets is going to simply be x plus y. The other equation is going to be 9x plus 4.7y, 4.75y equals 864.75. Again, elimination or substitution. I chose elimination just because that's my personal favorite. Substitution will work very well here as well. I'm going to multiply by -9. So I get negative 9x minus 9y equals negative 1,260. Add these two equations together, those cancel out, so I get negative 4.25y equals negative 395 0.25, divide by negative 4.25, and when I do that, I get that y is 93. I go ahead and plug that in. X plus 93 equals 43. I'm sorry, equals 140 minus 93 from both sides. So X equals 47. So then my sentence to wrap this up, the theater sold 47 adult tickets and 93 child tickets. So again, you get a point for the sentence, a point for solving, a point for setting up, and a point for defining your variables.